In this video, I'm going to show you how to create the engineering drawing for CNC Mill Project Number 1's Operation Number 1. First, you have to model CNC Operation Number 1's part. To do this, see the video on part modeling. If you've already done so, you're ready to start this exercise. Let's go File, New, and we're going to select a drawing file. Select OK. At this point, it's going to ask us to select our drawing template. If you've already downloaded the drawing template file off Polylearn and installed it in SolidWorks, go ahead and select the 144 drawing template. If you have not done this quite yet, please refer to the engineering drawing tutorial video. When I press OK, it brings up my custom sheet template there. And my model view is ready to go ahead and insert parts. I'm going to go ahead and press X at this point under model view, and we'll grab that tool in a little bit. And the first thing I'm going to do is go through and fill out the title block. So I'm going to use the note tool, come down here, type in the date, move over here, type in the material, 6061 T6 aluminum, and then last but not least, the title would be Mill Project Number 1, Operation Number 1 Model. Now press Escape in the Note tool, and we're ready to start inserting drawing views. Remember, to insert drawing views, we go to the View Layout tab. We can either insert a 3-view drawing or a model view. I prefer model view because it allows me to insert a pictorial view and select the exact views that I'd like to place. So when I click on model view, I go down and I hit the Browse tab, and I find my model, wherever I've saved it last. Remember, you want to save all of your drawing files, your assembly files, and your part files for one design in one single folder so you don't end up having file associativity problems later on if you were to rename the parts or move the files. Always keep everything together. So when I open Giorgio Op 1 Mill, press Open, it starts to create my views. Now, before clicking the mouse button, I come over to the side over here and I click on the Create Multiple Views icon. This allows me to pick the standard views, orthographic views, based off my part model. So I'm going to go with the front and the top view and the pictorial view. Moving down, I'm going to pick my drawing style. I'm going to have hidden lines visible. And then I'm going to use a custom scale of 1:1. When I hit the check mark, the drawing is created. The drawing views are created. Now, looking at the pictorial views don't often contain hidden lines. It overly complicates the pictorial view. So in order to change just that one single view, I'm going to click on the view, and then I can either on the left-hand side of the screen over here pick visible or wireframe only, hidden lines removed, or I could go up to the top of the screen and pick the same button, hidden lines removed. This gives me a nice pictorial representation of my part. Now it's time to start modeling the part, or dimensioning the part. We've already modeled it. So to do this, I'm going to use my Smart Dimension tool. So I'm going to go to my Annotations and my Smart Dimension. Now with Smart Dimension, I'm going to go ahead and dimension the overall length of the part. And notice my default units are set to 2 decimal places. So I could change that over here on the left, or if I wanted everything to default to 3 decimal places, I go up to the top, the Options, I go to my Document Properties. You definitely want to make sure you're in ANSI over ISO. And on Dimensions, I can pick 3 decimal places and press OK. Now, from this point on, every Smart Dimension I place should be 3 decimal places. So when I click on Smart Dimension, and I dimension from here to here, you'll see I've got the 3-place decimal. Now, looking at this dimension, it might be more beneficial to drag it down inside and have the arrows point towards the dimension. Remember, this one's not going to have specific tolerances on it. This is exactly the way you found your part, all the exact sizes. So it's really rare you would do something like this. Remember, it's an exercise on how to create geometry, how to model, and how to create drawings. So we're going to finish up dimensioning our part here with the Smart Dimension tool. We're going to grab this dimension here. We're going to grab the overall height of the billet. We're going to grab the length from that edge to that edge. Now notice, it does put a small gap right here. I can click on the dimension and make the gap a little bit longer or larger so it looks official. So I click on the extension line and I physically drag the dimension backwards. Right there. Now noticing, I've got my width or my length and my height dimensioned, and I see my drawing views have these tangent lines on here. This is an optional style thing that I'm not a big fan of. Notice you see where the radius starts and stops. To remove these, you can right-click on the drawing view, and it's called Tangent Edge. You want to remove the tangent edges from your drawing views. This makes a nice, clean profile around the part. All right. Now, looking at this part, we were going to dimension the overall height. We got to go ahead and do the radius, the radii. Now, since there's 4 of these radii, I'm going to go ahead and click on the dimension, move over to my dimension text and do 4 uppercase X space, denoting that there's 4 1/4" radii on this part. Now next, I'm going to go ahead and place a chamfer dimension. So to do that, chamfer dimension's underneath Smart Dimension. Select on chamfer dimension, I zoom in and I pick the hypotenuse and then the baseline that the chamfer's measured off of, and place that dimension. Now, looking at the overall part, you can see we've got the 1.877 and the 4.002 defined, the depth of the contour, the chamfer size, the overall part height, and then the radii size. So this part has been fully defined. The only thing that we're technically missing to fully define the part is the location of this contour. That location can be specified right here, from that edge to that edge. Oops, I had the chamfer dimension selected, so I'm going to grab Smart Dimension to do that. Go from that edge to that edge. I have the 50 thou there. And because this isn't something we would normally measure on a drawing, it's a reference, I can click on it and put the parentheses around it as a reference dimension. And then if I needed to go ahead and locate it vertically, I could do that by Smart Dimensioning from that edge to that edge. So noticing that this 0625 dimension is a reference dimension, we're going to click on it and hit the brackets as well. So those are the 2 reference dimensions we really don't care about for the size. In fact, the 2" was a reference, and so was the stock size technically, right? Because we didn't care about inspecting these dimensions. We cared that they were there before the operation. Actually, the 2 and the 4.1 we cared about. We didn't care about the offset around the part because that's just extra material. So now I believe we have fully defined this drawing. So when you're all done, you go File, Save As, save it as the same name as your part, Giorgio Op 1 Mill, solid drawing, save. And if you want to go ahead and save a PDF so you can print it out on any computer and bring it to class, go File, Save As, PDF, save. Now, that completes this tutorial on how to create a simple drawing based off your operation number 1 mill's parts dimensions. Have a great day.